Nachiketa, welcome on the platform. And yes, fine.
Yes,
Ready?
sir. Yeah.
Okay.
Yes, sir.
Yes, hello, Mr. Nachiketa. Welcome on YourPedia platform, and let's start your heat transfer snap for your final HPCL interview. Okay.
Okay.
What is heat transfer?
Sir, heat transfer basically is a study of science. It is a branch of science where we study about various modes in which the heat transfers from one medium to another. It is generally classified into three forms, that is conduction, convection, and radiation. Yes, sir.
Tell me something about the mechanism of convection heat transfer. How convection heat transfer takes place?
Sir, convection heat transfer usually takes place through the medium of fluids, in which if a fluid is present between two mediums, the heat will be transferred through to the molecular no, sir, that's for conduction. For convection, the heat transfer takes place due to movement of particles, sir.
Movement of particles.
Yes, sir. Yes, sir.
What is that? What do you mean by movement
Sir,
of particles?
suppose we have air in this room and I switch on the heater. The heat will be transferred through to me through the gas molecules colliding with each other, sir.
Achha, you heard about advection. What is the difference between advection and diffusion?
Sir, sorry, advection?
Advection and diffusion.
Sir, I don't know about advection, but I can explain diffusion to you, sir.
Okay, go ahead.
Sir, diffusion is, sir, the when in a system when there is some अगर कोई चीज है सर वो एक पार्ट पे कॉन्सेंट्रेटेड है एंड इफ वी आर अलाउइंग इट फ्री तो वो सर उस पूरे स्पेस जो उसके पास अवेलेबल होगी उसमें इक्वली डिस्ट्रीब्यूट हो जाएगी सर इस प्रोसेस को डिफ्यूजन बोलते हैं.
Okay, so which law of heat transfer actually governs convection heat transfer?
Sir, if I may recall it, I think it's Newton's law, sir.
Newton's law of cooling. What is that? Can you explain some brief about that?
Sir, it basically says that the rate of heat transfer will be proportional to the area of that surface or the body we are considering, and also it is will be proportional to the difference between the temperature of medium and the temperature of body.
Which area? Which area? Area you are saying which area?
Sir, area will be the surface area of the body that is basically emitting heat.
I just suppose if you want to consider the heat transfer, convection heat transfer from your body to the room air, which area
Yes,
you will do?
Sir, the area of my skin, sir. The skin of my skin.
Whole area, total surface area of your body.
Yes, sir.
Or only the area which is exposed to the air?
Yes, sir. The like I am covered right now with clothes I am wearing. So we will any area that is not in contact with the fluid will not be considered for.
What you need to say, the area which is in direct contact with the fluid. So that area only we will take.
Yes, sir.
Fine. Go ahead.
So then, sir, if we write in mathematical terms to combine these two equations, we use a proportionality constant because the convective heat transfer coefficient.
So the same equation is applicable to both forced and free convection. Q equal to HA delta T.
Sir, I think it applies to both, sir. I'm not exactly sure, sir.
Okay, but you need to be sure. This is a very simple thing because we are having H for free also, H for forced also. H for free and H for forced will be different, but the formula to calculate will be same, nahin?
Yes, sir. Yes, sir.
Okay, so which H is more? Like why H is more in forced convection?
So in forced convection, basically the when we consider forced convection, sir, since we are providing the motion for the heat transfer already to the medium, तो जब जैसे सपोज करें इस सरफेस पे सर अगर मॉलिक्यूल्स की डेंसिटी से मतलब जितनी ज्यादा मॉलिक्यूल्स होंगे उतनी जल्दी हीट इस सरफेस से निकल सकेगी. तो फोर्स में हम उसको मोशन का जो उसकी मोशन की रिक्वायरमेंट होती है वो हम एक्सटर्नल मीन से कंप्लीट करवाते हैं और उसको यस सर.
Free and forced convection. On what factors
Yes.
H depends in case of free and forced convection?
So in case of free convections, H depends upon force of gravitation acceleration, bulk modulus, temperature, the characteristic length of the cube, temperature difference between them, G beta delta T LC cube. Sir, the dynamic viscosity of the fluid.
Yes, go ahead, Nachiketa. What you mentioned on what factor H depends in case of free and forced convection?
Sir, in free convection, there will be 1, 2, 3, 4. Sir, there should be G. Sir, there will be almost 7 constant, 7 parameters on which free convection depends. These will be gravitational acceleration, bulk modulus, temperature difference, the characteristic
In
length.
case of what, like free or forced?
Sir, free convection.
Free convection.
Yes, sir.
So in free convection, there are only 7 variables.
No, sir. Free convective heat transfer will depend upon these 7 parameters.
No, but there are, I think, there are more.
No, sir. I think these are the only 7.
So you mentioned G. What about beta? Isobaric volume expansion coefficient.
Yes, sir.
But that is also there. You are missing, I think, that.
No, sir. I mentioned beta, sir.
So G beta. What about temperature difference?
Yes, sir. G beta delta T LC mu and rho, sir. This will be the constant on.
CP? What about CP?
No, sir. The CP will not take heat transfer.
No, it is going to depend. PP and K. It is going to depend on all these thermophysical property, rho, mu, CPK. You know, Nachiketa?
Yes, sir.
Rho, mu, CPK. So total variable will be 9.
Okay.
And in that, there are 8, what you can say, independent variable, and 1 is a dependent variable.
Okay, sir.
Fine. So you heard about the developing flow and developed flow. What is the difference between developing and developed flow, Nachiketa?
Sir, in developing flow, there is basically, sir, we will see that the flow does not have a characteristic as of now. The flow is very random. But once the developed flow is formed, there is certain area in which there is irregular or turbulent flow, and there is regular or laminar flow. This concept is mostly used in pipe flow, sir.
Can you tell me something about Wing's displacement law?
So Wing's
displacement law. What about this?
Yes, I have heard about this.
Somewhere in radiation part, this law is there.
Yes, sir. I'm not unable to recall the exact equations there. Sir, is it lambda into T equal to 2898?
Yes. That is the product of lambda T is constant.
Yes, sir. So it basically says that the monochromatic radiation and temperature will have a monochromatic radiation.
The wavelength corresponding to maximum spectral emissive power and the product of temperature, that is constant.
Yes, sir.
Or what you can say, a high temperature body is going to emit radiations of shorter wavelength. Their product is constant. It means what? The temperature and wavelength, they are inversely proportional. More is the temperature, lesser will be the wavelength. Are you getting?
Yes,
so high temperature body like sun, they emit radiations of shorter wavelength.
Shorter wavelength.
And the low temperature body like the interior of our room, human body, they emit radiations of longer
higher wave, longer
wave. Fine.
Yes, sir.
Nachiketa, what is gray body?
Sir, gray body is basically a body that has emissivity lesser than a black body, sir. It has emissive power basically less than a black body. Or most of the bodies we encounter in everyday life are gray bodies.
No, it's not very clear. Again, repeat once again.
Sir, gray bodies are those bodies which have emissivity and emissive power less than a black body. So these are bodies
that obviously emissivity of a gray body is less than black body. But how you can explain a gray body?
Sir, gray body. So sorry, sir, I'm unable to recall this right now.
Okay. How we calculate the fin effectiveness? What do you mean by effectiveness of fin, Nachiketa?
Sir, basically effectiveness of fin is that if in any जो भी हमारे पास सर हीट ट्रांसफर सिस्टम अवेलेबल है, तो उसमें अगर हम फिन लगाएंगे तो हीट ट्रांसफर कितने रेट से सर इंक्रीज होगा. फिन इफेक्टिवनेस इज बेसिकली that is the ratio of Q heat transfer with fin and heat transfer without fin.
What is Biot number and what is the significance of Biot number in heat transfer?
Sir, Biot number basically come action when we are considering unsteady state heat transfer. That is, the body's temperature will also change as we go on transferring heat from it. So Biot numbers is used to see whether that we can. Biot number is basically a ratio of internal conduction resistance to the external convective resistance. So it is used to find out whether we can use that equation for unsteady state, or we have to go for Heisler's chart.
So okay, when we can go with lumped parameter analysis, and what do you understand by lumped analysis?
Yes, sir. This is the exact answer I was saying to it. So lumped parameter analysis is say that we can consider the whole body from which we are transferring heat at the same temperature. And it can be only used when Biot number is less than 0.1.
Okay. What is NTU of a heat exchanger?
Sir, NTU of heat exchanger is basically a dimensionless area which is used to calculate the effectiveness of a heat exchanger. Sorry, sir. Effectiveness of a heat exchanger. It is given by the formula of UA by MCP small.
Okay. Okay, Nachiketa, I think now I can provide you the feedback, huh?
Okay.
देखो आपका इंटरव्यू कब किस डेट पे है?
Sir, 1st March को.
अभी टाइम है आपके पास, यू आर हैविंग सफिशिएंट टाइम, तो इट इज एन एडवांटेज फॉर यू. अभी रिवाइज करो, वॉच मैराथन क्लासेस ऑफ ऑल इंपॉर्टेंट सब्जेक्ट लाइक थर्मोडायनेमिक्स, हीट ट्रांसफर, फ्लूइड मैकेनिक्स. अभी थोड़ा सा आपका अंडरस्टैंडिंग है, यू आर लुकिंग कॉन्फिडेंट, बट थोड़ा सा आप नर्वस हो जाते हो, है ना, क्योंकि आपने चीजों को अच्छे से रिवाइज नहीं किया है, ब्रश अप नहीं किया है कंसेप्ट. तो इंटरव्यू में क्या होता है, यू नो, वी आर हैविंग वेरी मिनिमम टाइम टू इंप्रेस द इंटरव्यू. यस, वी आर यू नो वेरी कंसेप्चुअली.
सर आपकी आवाज कट गई सर. सर
हाँ, तो मैं आपको क्या बोल रहा था, थोड़ा सा आपको रिवाइज करना पड़ेगा सब्जेक्ट्स को. ऑडिबल?
ओके सर. यस सर.
सब्जेक्ट्स को थोड़ा सा रिवाइज करना पड़ेगा. और फिर अगेन मेरे साथ कुछ स्नैप लगाओ. रेगुलरली यू कैन ज्वाइन. अगर आपको कंफर्टेबल है 7 to 8 के बीच में, तो यू कैन ज्वाइन मी. ठीक है, एक दो दिन का गैप देके रिवाइज करो सब्जेक्ट को, तो थोड़ा सा आप हैबिचुअल हो जाओगे, प्रैक्टिस हो जाएगी. ठीक है.
ओके सर.
और मेरे को लग रहा है कि पोटेंशियल है आपने, क्योंकि कंसेप्ट तो ठीक है, मतलब ऐसा नहीं कि आपने चीजों को नहीं पता. आज मैंने पहला स्नैप था, तो आई आस्क्ड यू वेरी बेसिक लेवल क्वेश्चन. नेक्स्ट टाइम हो सकता है कुछ और एप्लीकेशन बेस्ड क्वेश्चन पूछ लूं आपसे. ठीक है, राइट सर. जैसे हम आगे बढ़ेंगे तो हमारा प्रैक्टिस अच्छा होता रहेगा.
ओके सर.
तो उसमें थोड़ा सा मेहनत करो आप. आज ठीक था, आई कैन से कि एवरेज तो था, है ना, बट थोड़ा और आप बड़ा क्लोज हो, क्योंकि थोड़ा एफर्ट पुट करोगे नेक्स्ट 10-15 डेज में, यू विल रीच टू अ वेरी गुड लेवल. ठीक है सर. हाँ, फिर यू कैन गेट बैक टू मी एनी टाइम. गुड लक. थैंक यू.